Well, dear students, good morning. I'm here to explain you the concept of absolute temperature with the help of root mean square speed of the molecules of gases. In the last video, I derived the expression for pressure exerted by the gas on the wall of the container. Now, concept of temperature is also related with root mean square speed. From kinetic theory, of gases, the pressure exerted by the gas on the walls of container is given by P is equal to 1 upon 3 m into n upon b c square bar, where m is the mass of each molecule, small m, mass of each molecule of the gas. M is the mass of each molecule of the gas in the container. N total number of molecules. V volume of the container. V is the volume of container. C square or C bar is the root mean square speed or velocity. Now, if the mass of gas be capital M total, then M into N is equal to capital M, total mass of gas, total mass of gas in the container. So we can write PV equal to 1 upon 3 mc square bar. But from ideal gas equation, we have learned but from ideal gas equation, PV equal to RT for 1 mole, and let this mass be equal to 1 gram molecular mass. Also, if capital N be 1 gram molecular mass, I have told you, for example, 1 gram molecular mass, 1 gram molecular mass is equal to mass of molecular mass taken in gram. For example, 44 gram CO2 is equal to 1 gram molecular mass. I keep on repeating this thing because this creates lot of trouble for students. What is gram molecular mass? Molecular mass of gas taken in grams is called gram molecular mass. Then by comparing the two we get that RT is equal to 1 upon 3 mc square bar, or R is equal to 1 upon 3 m upon R into c square bar. Since for a given gas, m upon R is constant. So P proportional to c square bar, or you can write c square bar proportional to T also. From this c square bar यही लिखे ना, और c bar proportional to under root T. T, absolute temperature of the gas. If T equal to 0 Kelvin इसको हम कहते हैं absolute 0, तो C bar is 0. C bar have told you is the root mean square magnitude of root mean square velocity. It becomes 0 only when C bar becomes 0 if motion of every molecule gets seized. क्योंकि C bar जो है अंडर रूट C1 स्क्वायर प्लस C2 स्क्वायर प्लस C3 स्क्वायर प्लस so on up to Cn स्क्वायर upon n. If all these motions, these velocities are 0, only then C bar will be 0, and therefore absolute 0 of temperature is the temperature at which motion of every molecule gets seized. Motion of every molecule gets seized. Seized means stop. A molecule of gas in the container has no velocity, then the gas is at 0 Kelvin. Actually, I told you temperature scale. While constructing or making the scale of temperature, initially the 0 degree centigrade or 32 degree Fahrenheit was supposed to be lowest temperature in that scale. In your thermometer, clinic thermometer, 0 degree centigrade, which is based on thermal expansion of mercury. to absolute zero, although it is imaginary, because before reaching this temperature, every gas gets first liquefied and then solidified. But we have got the concept of absolute zero of temperature, means which temperature is actually zero. तो वो temperature is that temperature at which motion of molecule gets ceased. As you know, by observations, when you heat water, molecules of water start moving here and there quickly, and therefore temperature is also the measurement of root mean square speed. Temperature is also the measure of root mean square speed. Now I come to very important topic from cancer of gases. Internal energy of ideal gas. Internal energy per mole of ideal gas. Dear student, generally I revise the topics in brain when I start making this video, but sometimes I come naturally. So while writing the heading, I keep on thinking what is the correct heading. So one mole, 1 mole of any gas is equal to its 1 gram molecular mass. For example, I told you just 44 gram of CO2 is equal to 1 gram molecular mass. Molecular mass of CO2. Please add to this is equal to 1 mole of CO2. Actually, concept of mole. One of my friend went to seminar at large distance from our town. Then I started my teaching career. I asked them what happened in the seminar. What have you learned from seminar? And what was the method there of teaching, etc. So he told that first subject expert explained so many facts, and then they asked if you don't understand any topic, now you please ask us. My friend asked concept of this mole. Sir, I don't understand what is mole. Though he much learned from with respect to me. He joined degree college later on. Then I asked, did you get that it there? He said, no, I could not. Then I explained him very easily and he was very happy. It is so simple. So concept is there that gram molecular mass, 1 gram molecular mass of gas is equal to its molecular mass taken in gram. So 44 grams CO2 1 mole. Similarly 32 grams oxygen 1 mole. And 1 mole of every compound or 1 mole of every element has 6.023 10 to the power 26 molecules or atoms. So here I am starting, suppose, let in a container we have 1 mole of an ideal gas from kinetic theory. From kinetic theory of gases, the pressure of gas is given by P equal to 1 upon 3 m upon v into c square bar. Now I've written clear to you. Or PV here equal to 1 upon 3 mc square bar. Here m is 1 gram molecular mass of gas. But when you calculate the mass will be placed, C or P, anything, mass have been placed in a kilogram there. Now, from ideal gas equation, but from ideal gas equation, PV equal to RT, and therefore 1 upon 3 mc square bar equal to RT, or mc square bar 3RT, or half mc square bar is equal to 3/2 RT. Dear student, I have told you this expression while teaching thermodynamics also. 1 upon 2, but 1 upon 2 mc square bar is equal to kinetic energy of 1 mole of gas. 1 gram molar mass. It is sum of the kinetic energy, I should say, and it is called internal energy. And is equal to, and this sum of kinetic energy of molecules present in 1 mole of ideal gas is called internal energy. Is called internal energy. Written by capital U. So I can write here, so internal energy of an ideal gas at temperature capital T Kelvin is given by UT equal to 3/2 RT. This is the theoretical value of internal energy of gas based on kinetic theory of gases, and therefore kinetic energy of each molecule is equal to ut upon n equal to 3 by 2 r upon n t, where n is the number of molecules in 1 mole of gas, is equal to Avogadro number, n Avogadro number. But R by N and hence kinetic energy per particle, per molecule is equal to 3 by 2 kBT. Dear student, here it is very important concept. Kinetic per particle, Kb universal constant. So this kinetic per molecule independent of mass of particle molecule. So we can generalize this equation. Kinetic per particle when the system of particle in equilibrium at temperature T. यानी कि if electrons are at temperature T and proton is there, both have same temperature, then kinetic energy per particle, यानी kinetic energy of electron and proton or neutron, whosoever is the same. And hence here Kb, I told you Kb equal to R by N, and Kb here Boltzmann constant. Boltzmann's constant. I have explained you its value also, unit also. Joule per mole is the unit. So we can generalize this 3 by, though we have derived this expression for molecule of gas. But if there is any system of particles at temperature T, maybe system of proton, maybe system of electron, neutron, or any gas molecule, whether it is CO2 or nitrogen or any other polyatomic gas, but kinetic energy per molecule is same. Very important fact. Don't get confused कि भाई एक CO2 molecule है, mass 44 है, hydrogen molecule है, only 2 है, so it should have large energy. No. From kinetic gases we have got here that kinetic energy per molecule or per particle is 3 by 2 kBT. It is from, remember, it is from kinetic theory of gases. I will tell you something mistake here later on, but this was the topic here today. In this next video I will take some more topic about this internal gas, internal energy of gas. Thank you.